Greetings, the Astro 30 here again, and today's little project is to mount this frequency meter module finally into a case. Now, I found this case at JCar, which when it's together it looks like that with some rounded corners, a bit of leftover manufacturing stuff just fell out. Yeah, and its measurement is about 130 millimeters by 35, we'll say, and the total depth is 90. So it's a small case. It looks like a case you'd mount a clock in, really. And with these standoffs here and here, which mount the top half together because there's screw holes on the inside of this, I found that mounting this module, or setting it round about there in the middle of the case there at the front, there is just enough space forward and backward to fit it, including having the front panel on. Now, I was hoping this was semi-translucent, but it's not, which means I'm going to have to cut a square hole in it. Now, I don't have a diffuser for this. I do have a piece of red perspex, this stuff, but as you can see, it's at least 3 millimeters thick, so even if I wanted to replace this panel just with this perspex, it's not going to work because it's too thick. It's actually twice as thick, so that's not exactly going to work. However, I can cut a piece of this out and then actually put it over the front of this with screws going through the inside, just to give it some sort of, diffusion. I'll think about that in the process, but first of all, what I've done is I've worked out roughly where the screw holes are. Now, I measured it on here, and I found from center to center it's 84 millimeter long, and from center to center downwards, or up and down, it's 18 millimeter. So I first worked out where the center of this piece of plastic is, and drawn a line, and then I've gone roughly 20 millimeters in this way and 20 millimeters in that way, and that worked out to roughly 84. It doesn't have to be perfect. And then I've gone 9 millimeters either side of that line for the other two screw holes. So the first thing I'm going to do is, before I worry about even cutting out a square hole, because I've got several methods, and this is pretty thin, I could probably do it with a utility knife anyway, but I'm first going to drill these holes, which are going to be roughly 3 millimeter, and then I'm going to work out, well, I think it's only about 5 millimeter in, probably make it a little bit less, but then work out how big I need to make the cutout and where to put it. So first things first, I'm going to drill these holes, but before I do that, that particular case is a HB5960 for those of you playing along at home. I also went and got another one of these 9 volt, I think they're 500 mAh, yeah, 500 mAh it says on it, switch mode power supplies, power pack adapters, whatever you want to call them, with various different types of connections there. So I've got 2 of these, and that's going to power the unit because I know it runs fine on a 9 volt battery. I should say that runs not fine on a 9 volt battery, the plastic case doesn't run on anything. Went and got one of these, which is a QC1902, which is a 1x and 10x oscilloscope probe. Unlike the other one that I bought, which it turned out to be a 250 megahertz times 100, which is practically pretty useless. So that's going to be used for both an oscilloscope and for, plugging into this, because I've got my last 2 components there. I've got a BNC female socket, and I've got a 1.2, I think it is, or 1.5 5 millimeter DC adapter socket, which is panel mount. Because there's not going to be any room on the front panel for the input socket, well, very little, and I don't really want to jam it up at one end, what I'm going to do is I'm going to mount both the DC socket and the input socket on the back panel. So that's my little project for today. Shouldn't take me too long. The only hard part is cutting out the square hole. But first I'm going to drill those 3mm holes that I said I was going to drill about 50 million years ago, and then go from there. Okay, I've got a 2mm drill bit, and I'm having to work on the floor because, well, the drill press is too heavy to put on the table, or I should say the table is too weak to hold the weight of this thing. This thing weighs about 30 kilos easily. Anyway, I'm starting with the smallest drill bit, and the smallest I know that the drill press will actually accept in the chuck, which is 2mm. Anything smaller than that, it just won't grip it. I'm just going to see how the holes line up with the module. See, those two holes were way off. Well, so much for my measurement. Huh. Those holes are way wrong. Yeah, they're way off. What a bugger. Okay, it helps to actually measure twice and cut once. I'm now using the back panel, so I use the other panel as the back panel. It's not really that big of a deal. I just want to make sure that I've got it right this time. I didn't have these lines square. One was like way off, crooked towards the bottom, so that's why the holes ended up off. So I've now believe that I've got it right this time. So I might actually mark with a permanent marker the actual dead center of those holes to make it a lot easier to see what I'm doing. Or a whiteboard marker works too. I'm going to draw one there. So if I enlarge these holes, should be enough to massage it, I suppose. So I'm going to change my drill bit. That's those 4 holes drilled. So I'll just have a look here. Yeah, that lines up almost perfectly, so I'm actually quite happy about that, because I should be able to get 4 screws in there nicely, and it'll mount it to the front panel okay. Maybe I should actually try putting some screws in and see if it does actually line up properly. So I've left myself plenty of wiggle room here, so yeah, they're going to line up just nicely. But what I want to do is I want to actually screw it up and then mount it in the case. See, well, clearances. Make sure it clears everything properly. I'm not going to do it up super tight, just tight enough to. Okay, so this large area was the front. No, it was the small area that was the front. Yeah, it clears the 2 mounting posts nicely. So when I mount the top cover, everything's still nice and flush. So I'm happy. Now, what I want to know is, what would happen if I powered up the module? Would any light actually come through this? Probably not. But because it's so thin plastic, it's worth a try. Okay, so I'm just going to power it up. You can actually see it, which is interesting. So it's not very bright. If I take direct light off of it, you can actually see that it's lighting up. So I'm just wondering whether or not I should just leave it without cutting a hole in it, and just leave it like that. I mean, the display won't be very bright, but at the same time it saves a lot of work. So what I might do now is I might drill a hole for the input socket and the power socket, and then I will go from there. So this will need roughly a 7mm hole. This will need roughly a 9mm hole. So I'll just go do that. You don't really need to see me doing that. That should be it. Yep, perfect. Oh! Shit, occupational hazard. Banging my head on shit. Okay, so there we go. That's the holes drilled that I need. That's the inside edge. So I'll start by mounting the BNC. Never did really like these type of BNC sockets because they have the tendency when you drill a hole, unless you do it in metal of course, as soon as you start tightening it up on the outside it just starts turning or strips the hole that it's sitting in. They're very finicky things to work with, and especially working with ABS plastic, it's hard to get these super tight. So, but you do your best as you can. Now I'm going to mount the DC socket. Oops. And then I'll find a pair of pliers, ball nose pliers, and tighten those nuts. It's not exactly straight, but that's about as tight as I'm going to get that one. If it proves to work loose in time, I will tighten it again. But for now, it'll do the job nicely. So that's the two sockets mounted. Now I can bring this other half back and see, well, that DC socket's awfully close to that pillar, this mounting pillar here. So I just may have to massage that. Luckily the terminals are facing the other way. Yeah, now the DC socket's in the way. Maybe if I could always turn it over the other way, see if that makes a difference. Well, it's going to be equidistant, isn't it? Although that might look a little bit better than the other side, so I'll try that way. Yeah, well, it clears it, so saves making any adjustments. Okay, so now what I've got to do is determine where the positive and negative posts are on that. The easiest way to do that is to plug in the power. I'm pretty sure where I'm seeing that this down here is where the center is, and that's a negative. No, the negative's over there. There we are. So that's my negative, that's my positive. So I need to bust out a soldering iron and wire up these two connectors to their relative sockets. So I need to warm up a soldering iron. And whilst I think about it, before I get too excited here, is what I should do probably, which would be a very good idea, is to remove the protective film that they've got over the top of these LEDs, or the displays I should say. Doing that might make the display a little bit brighter too, because this has been sitting on here for 2 years. So there goes that. Now I can put the thing back together. Whilst I'm waiting for the soldering iron to warm up, I've just got it sitting over here on the bench. I'm not worried about putting it in a holder or anything at the moment, because I've only got to solder 4 wires. So I'll just put this back together. And now that I know that the light will come through this panel, because it's semi-translucent, I'm going to tighten these screws down for real, for the final time. as it doesn't need to come apart. And this project that I'm doing now has been sitting around for 2 years waiting for me to mount it into a case, and I've just never got around to it because I've just been either working too much, too lazy, can't be bothered, whatever. Yeah, the display's a little bit crooked there, but yeah, it is what it is. Now, on with the show, and that is mounting these wires to the sockets. So, first of all, I'm going to do this one. So I'm going to do them one at a time. I'll put a pair of pliers on that to hold it steady. Okay, so that should be warm enough. Yep. Okay. So got the shakes at the moment, I don't know why. That didn't really take all that well. Okay, that's a bit better. Now, these wires are already pre-tinned when the kit was assembled, so I don't need to do anything except solder them into the relative positions where they need to be soldered to. Make sure that was soldered properly. I think that's soldered properly. Now for the input one. Don't want to put too much heat on that because it will melt the plastic that it's mounted to. There we go, that should be soldered. Now for its center, turn that around. So what might be a better idea is to tin this first, like that, and then bring my wire up to it. There we go, done. So that's the wiring part done. Now I need to bring this back in, this back in. I've got to figure out which way up this module is now, because I have absolutely no idea. So power is on that side, so that's this one. The input's on this side, so that's that one. So we put the wiring in the middle there like that, put that in there, and then I'll plug in the power, which is not plugged into the power point, which why nothing happened. There it is. Okay, I can see that that module's upside down. So if I turn it the right way up, it might help. Put these wires in. I'll just pop the lid on. Actually, I know why it's upside down, because this is the actual top, not the bottom. So if I put this around the right way, which is the wrong way around, then put this on top, the right way around, then turn it over, something's not quite fitting right now. What's going on here? Probably that wire's getting in the way, or the wires are getting in the way. Make sure the wires are free of the posts. That's better. So you can see it, but we've got a bit of noise on the display because but there's no input connected. Alright, connecting it to the local oscillator of this radio, it's a little bit more stable. See, it's 2 megahertz there, and 983 there. So once you've got it connected to a circuit, it settles down, but once it's I didn't even check if that was on times 10 or times 1, it's on times 1. So once you've actually got it connected to the circuit, it settles down, so I'm quite happy with that. I mean, the display is pretty dim, but you can still read it, So I'm not really particularly worried about it, the display doing that when there's no input connected. It'd probably work better if it had shielding, but it's perfectly fine. Now to put the screws in. Now, should I have cut a square hole in the front? Probably. But why do extra work if you don't really need to do it and it still gives satisfactory enough results? That's my motto. So I'm quite happy with the way it turned out, even though when I started drilling the back panel I made a mistake and got it all off, and so I had to drill the front panel. Now this comes with some feet, 4 of them, which is stuck to this, which go over where I've just put the screws. So I'll pull out one there, put him there, and one there. So if you ever want to take it apart, you've got to remove the feet. But seeing as this thing does not take batteries or anything, I don't need to. So now that's not going to slide around the desk. And there we go, it's finished. Anyway, I'm the Astro 30, and if you enjoyed this video, please remember to rate, comment and subscribe, and you can always follow me on Facebook and Twitter. The links are in the description. Anyway, this is the Astro 30 saying see ya, have a great day. Can't believe I banged my head on video.